So here I've drawn a few diagrams of some different data link types. So on the left here, this is a simple point-to-point data link. And the way it works is pretty simple. So these two computers are connected, and if one of them wants to send information to the other, then it just puts that information into frames, as we've seen, and the other computer is directly connected, so of course it'll just receive those frames. So in practice, when building networks, we don't tend to have a lot of point-to-point data links like this. This is point-to-point. In practice, we don't tend to have a lot of these point-to-point links. The place we do see point-to-point data links is very commonly in larger networks like internet service providers. These networks will often use point-to-point links, often between networking equipment in different cities like this. And so physically, these links are probably like fiber optic, since they tend to cover long distances. And so I want to compare that now to a different type of data link called multipoint, or sometimes it's called broadcast data link. So with point-to-point, we just had two computers, right? One at each end of the link. So with multipoint, there are potentially many different systems sharing the same data link. So like in a wireless network, for example, any of these computers can send data to the other computer that's part of the same wireless network because they're all sort of sharing the same radio waves. And then down here, this is an example of a cable residential broadband network. And so we've got a shared cable system that multiple homes are connected to. And this is also a multi-point network. The cable modems in each of these houses all share this same data link and can communicate directly with each other if they want. And finally, another very common type of multi-point network is Ethernet. So this is Ethernet down here. And it's also a multi-point type of network because we have multiple connections here connected to this Ethernet switch. And so any of these computers can send data directly to either of the other two computers through the switch. So in previous videos, we talked about the importance of framing data, but now I want to talk about what data goes into the frame. And so we'll start with Ethernet. And so this is the format of an Ethernet frame. And we've already talked about the preamble and start of frame delimiter, which, if you remember, it starts out 101010 and so on and so forth until it finally gets to 101011. And then remember, when this preamble, this final 11 is kind of the start of frame delimiter, and that means that the next bit starts the data that's in the frame. And so the very next thing after this preamble is always something called the destination address. And this is always 6 bytes long. So this is 6 bytes long of destination address. And then following that is the source address, which is also 6 bytes. And so these addresses are important because Ethernet, as we just talked about, is a multi-point data link protocol. So we can have more than just one other computer connected to the same Ethernet network, like we have here with these 3 computers connected to the switch. So each computer has a unique Ethernet address. And here's some examples here. And these addresses are called Ethernet addresses, or sometimes you'll see them called MAC addresses. And that stands for Media Access Control Address. And these addresses are built into Ethernet hardware. So various manufacturers of Ethernet hardware coordinate to make sure that these addresses are all unique. So anytime you buy a computer, or you have a computer that has an Ethernet interface on it, it'll have its own unique address kind of baked into it. And so each computer has its own address. So if computer 1 over here, so this is computer 1, 2, 3, if this first computer wants to send data to computer 2, then what it'll do is it'll put computer 2's address into the destination, and then it'll put its own address, computer 1, as the source address. Then if the switch knows about computer 2, it'll just forward the frame to computer 2. And if the switch doesn't know about computer 2, then it'll actually just forward the frame to all of the other computers, and then computer 3 can just go ahead and ignore it. Alternatively, if computer 1 wants to broadcast data to all the other computers on the Ethernet network, it can just set the destination address to a special broadcast address, which is all ones, or in hex, that would be all Fs like this. So setting the destination address to this means that every computer connected to the Ethernet switch should receive that frame and process it. The next field in the Ethernet frame is the ether type, and this is a 2-byte field. It's a 2-byte field that basically just tells us what format the payload is in. So once we receive a frame, we want to be able to read this payload, and the ether type gives us some idea of what to expect in the payload. So in most cases these days, like the payload is going to be an Internet Protocol packet or IP packet, and in that case, like the ether type is just going to be 0800, which just means that the payload is IP. But there could be other types of payloads, and in that case, the ether type would tell us exactly what format to expect here. And the payload itself is usually between 46 to 1500 bytes long. Although in some cases, there's some high performance networks that use jumbo frames, it could be as much as 9,000 bytes long. But in any case, the last 4 bytes of the frame make up the frame check sequence. And the frame check sequence is basically a number that's computed based from the contents of everything else, so the destination address all the way through to all of the payload. And it's used by the receiver to detect, corrupted data in the frame. So the sender will compute the frame check sequence based on all of the data in the frame before sending, and then put that in as the frame check sequence. And then the receiver will sort of compute that again when it receives based on the data that it receives. And then if the receiver's computed frame check sequence doesn't match what the sender computed, or what's in the frame actually, then the receiver will just assume that it didn't receive the frame correctly, and it can just ignore the frame. And then at that point, it would be up to the sender to try to resend it. But we'll talk about that more in later videos. So finally, I wanted to compare the Ethernet frame format to another type of frame format, just so you kind of get a sense that there are other formats out there. And so this is the frame format for PPP, which is the point-to-point protocol. So you'll remember up here where we're talking about the difference between point-to-point and multi-point links. So PPP is actually one of the most common framing formats used on point-to-point links, particularly in larger network backbones like this. So if we go back down here, PPP uses the same HDLC framing that we talked about before. So there's this flag byte at the beginning, which is it's 0, 6 ones and a 0, and then same thing at the end here. And so we talked about this before at the beginning and end of the frame. And then also remember, it's going to do bit stuffing or byte stuffing for everything else between the flags here to prevent any data from being mistaken as the flag. And so the first 2 fields here are the address and control, and each of these is 1 byte long. And it may seem strange to have an address for point-to-point links. So since, if you send something on a point-to-point link, there's only one place that it's going to go, which is the other end of the link. But I don't know, perhaps to allow for future flexibility, when PPP was designed in the early 90s, they, I guess, decided to add this address field. But it's always set to just all ones or FF in hex. And same thing with the control field. It's always just set to 03 in hex. And I guess over the past 20 years, no one has figured out what any other use for these fields. So they're always just set to these values. And then the rest of the fields are basically the same as Ethernet. So the protocol field serves the same purpose as the EtherType field. And so it's 2 bytes long. And then the payload, of course, is the payload, the same as Ethernet. And it's usually between 40 to 1500. But of course, it could actually be smaller or larger. And then the frame check sequence, again, it's 4 bytes. And it works the same way as the frame check sequence it does for Ethernet.